Our son, what's your favorite color? What's your second favorite color?
Black.
Black. All right, come here. Here's the scenario. He is the black X in a campground. The blue stuff is a river.
Okay.
You're at your campground.
Yeah.
You spontaneously human combust, and now you're on fire.
I'm on fire.
Excellent.
Yeah.
There is no water in your campsite.
Okay.
The only way to put yourself out is to run to the river. Could you please carefully show us what path you would follow to get to the river?
Oh, that's going up. Like that way.
Okay, thank you very much. Let's give it up. Shh. Thank you. Kira, what's your favorite color?
Blue.
Other than blue?
Green.
Green. Light green or dark green?
Light green.
Light green. Strangely enough, there might be something weird going on in this campground because you're also in the campground. You're over here, and you burst into flames. You're on fire. Show us what path you would run to the river. Okay. Excellent. What's your favorite color, Tom?
Red.
Red. There's something with this campground because you've had the same scenario. Ooh. 2 out of 3. Okay, let's back up. Why did you run the path you ran?
I thought since it was going up, it'd like be closer. Like I guess not. Like the river's going up.
So how would you, in second thought, how do you think you would have run?
Probably down.
Down?
No, it would be like
Straight down?
maybe like at an angle.
At straight down at an, all right, let's just, here. We could be spending all day having you describe the path.
Like. Yeah. That way.
All right. You like that better?
Yeah.
Those of you that didn't burst into flames, why? Hold on, let's back up. Do you agree with that?
Yeah.
You would all run in the same path. Why?
That's the quickest way.
I'm sorry?
Quickest way is the exact distance. That's
Shortest
wrong.
distance.
Shortest distance.
What makes that the shortest distance?
Because there's nothing
you went
in the way.
There's
What if
nothing,
there's a
well, there's
tree?
nothing in the way if he goes the other way too. It's just taking longer.
Because getting to the place.
What's special about all those distances? Now we have to start thinking math.
Different pace
Hmm?
different pace and correctly was knowledge. That's wrong.
Let's reduce to some math terms here. I've got a line and a point.
Perpendicular.
Is that you? Jack? They're perpendicular. Okay. The three of you that burst into flames, do you agree perpendicular?
Yeah.
Okay. We'd want this to be perpendicular, we'd want this to be perpendicular, we'd want this to be perpendicular. Sounds great, but you still haven't answered my question. How do we know that's the shortest path? How do we know that that path is shorter than the first one that our son ran along? So? How do you know?
Because it's 7-degree angle.
So? Okay. Patrick?
Well, it looks like in the picture that his point starts farther back and then everyone else's.
Do you think that matters? If I started, I happen to like the color orange. If I started all the way back here, and I would run perpendicular, I would get something that looks like that. for me, that's still the shortest path, right?
Yeah.
That would be shorter than, let's say, this. But again, the question is why? What makes path number 1 shorter than path number 2? Okay,
Because of the angle.
keep going.
Like, how it's like kind of curved too.
Well, okay, I don't know what happened here. Maybe I had to run around a sleeping bear or something, but we'll assume, I mean, honestly, he's on fire, so we would like to see him run in a straight line, but he's on fire. So, and this isn't very practical, because if you're on fire, you're just gonna do something like that.
Or you stop, drop, and roll like you should.
Probably, yeah.
This problem could have been avoided.
So, why is 1 shorter than 2?
Because 2 has more of an angle
Yeah,
than 1 does.
uh-huh.
So
That's not a false statement, but how does that prove that 1 is shorter than 2? What do you got?
Like the path 2 is steeper than
So,
the big line.
why?
Steeper.
Why? Now we're gonna get in the circle here. It's steeper, takes longer, steeper. I'll give you a hint.
It's the hypotenuse of the triangle.
Say what?
It's the hypotenuse of the right triangle.
What does that have to do with anything?
Because the hypotenuse is always along the side.
Beautiful.
Well, if you were to change.
Because the shortest path that we identified for all 4 of us is forming a 90-degree angle, any other path, so if we go to, who was red?
I was right.
You were green.
Yeah, you can.
Okay. So if we go to you, Tommy, any other path we draw is going to be the hypotenuse of some right triangle. Okay. We have one leg here, we have the other leg here, and therefore that other distance would be a hypotenuse, which would be longer than the starting distance. Okay. So that's a long-winded way of saying the shortest distance between that point and that line, which is what we have on this slide, is along that perpendicular. Okay, you got that? That's also the distance that we're going to use to measure the distance of a point from a line. Okay, so now we get into the math here. Let's start with a point at -2,5. And we know the equation of the line is y equals -3x plus 10, I think. Yes. I'd like to know D. I'd like to know how far that point is from the line. I'd like to know how far I have to run if I burst into flames at -2,5 and the equation of the river is -3x plus 10. That kind of breaks down when you get into the math here. What do you need to find the distance on a coordinate plane? 2 points. Do I have 2 points?
Yes.
No.
What?
I have a point.
But like,
Ethan, what do you got for me?
in the equation,
Yeah.
wouldn't that mean that one of the points is 0, 10?
That is true.
But we don't know where that point is? Is that-
Correct.
Okay.
What point do we need?
Something to understand.
In that picture, what point do we need? Kaylin? Good. That one there. Can we find that point?
Yeah, it's
How?
straight.
So, good.
Finding the midpoint
Of
of the line.
lines don't have midpoints. Remember, they go on forever.
And you use the other side.
Of that blue line?
Midpoint of the blue line would not.
I mean, not the midpoint, the end point?
Correct. How?
I don't know.
Okay, so let's call this point, we'll call this Q, we'll call this P. How do I find the location of Q? This problem takes all of the things we've been doing up to this point and puts them together. So all the puzzle pieces start to fit together. Go ahead, Sean.
the equation for P, the line PQ.
Oh, good. Okay, hold on. Find the equation of the line PQ. Okay? How?
By writing the positive reciprocal of the other equation.
Nice. Okay. What's the slope of this line, everybody? -3. Okay, we'll call that M1. So, Sean, staying with your idea here, what's the slope of M2? 1/3. What are the two things we need for the equation of a line?
A point and a slope.
Point and a slope. Do I have a point?
Yeah.
Do I have a slope?
Yeah.
Yes. So therefore, I can come up with the equation of the line PQ. So PQ would have the equation y minus 5 equals, whoops, not negative 1/3. 1/3 times the quantity x plus 2. Yes? Okay? Keep going, Sean. Now what?
Do you use substitution or for the other equation?
Excellent. In general, what are we going to do?
Find the intersection between the two lines.
Beautiful. I have two lines now, PQ and that black line that we know the equation of. I want to find the point of intersection. Finding the point of intersection between two lines is the same thing as solving a system. So I'm going to solve the system between y equals -3x plus 10 and y minus 5 equals 1/3 times the quantity x plus 2. And you want to use substitution? Okay, that's fine. It works out nice because I have one equation already solved for y, so I can take that and plug it into the other equation. All right, so starting on a new slide here, see if I can remember this. Y equals -3x plus 10, and the other one was y minus 5 equals 1/3 quantity x plus 2 or minus 2? Plus 2. Okay, and Sean said he wants to do substitution, so -3x plus 10, and I would get in the habit of putting that in parentheses just to be sure. 5 equals 1/3 x plus 2. So that gives me -3x plus 5 is equal to 1/3 x plus 2/3. I don't like fractions. If you want to work with fractions, that's fine, but I'm going to take an extra step here and multiply this whole thing by 3 because I want to get rid of the fractions. -9x plus 15 is equal to x plus 2. So that's 10x is equal to 13. So x is equal to 13 tenths. Not a pretty answer, but that's okay. We'll work with it. All right, fire up your calculators. Tell me what I get if I take 13 tenths and put it into that top equation because it's already solved. Y is equal to -3 times 13 tenths plus 10. Tell me what y is, please, in a simplified fraction. Can I get a confirmation, please?
Yeah.
Yes, 61 over 10. Okay, therefore, Q is located at 1310, comma, 61 tenths. Good. But that doesn't answer the question. I want to know how long is D. Now what? Perfect. Find the distance between P and Q. How are you going to do that? Oh gee, what did we do for homework last night? Distance formula. Okay, for those of you that have the distance formula up and running, go ahead and run it. You can put fractions into the distance formula, you just do it as a division problem. 13 divided by 10, 61 divided by 10. So find the distance between -2.
Do we put it in parentheses? For the
You don't have to.
Oh.
When you put it in for x1 and y1 or x2 and y2, you don't have to.
Yeah.
You'll get two answers. One will be a weird square root. I don't think it turns out nice in this case.
Yes.
Or it'll be a decimal. The square, yeah. It's kind of a math faux pas to combine decimals with radicals. So we're just going to take the decimal value. What do you guys have? 3.48. There you go. Distance is equal to 3.48. Or what?
87.
Oh, you converted that into a fraction? Oh, look at her. Did you convert 3.48 into a fraction? Yeah, don't do that. Because the program is set to round it to 2 decimal places.
No, I did the answer.
You took the answer and converted it. Okay, good. And there's the answer to our problem. All right, so let's talk about the process first. What's confusing? Number 1, do you understand what you're being asked to do? Number 2, can you find that point? Q. Well, I should say, number 2, can you write the equation of the blue line? Okay, we're taking that segment that connects the person on fire to the river and turning it into a line by finding the slope coming from the opposite reciprocal. The opposite reciprocal comes about because of this 90-degree angle down here in the corner. That guy right there. Therefore, you have the point, you have the slope, you can write the equation line. Then you solve the system using elimination or substitution. Most of the time, substitution will be easiest in this case, but it's up to you. And then if we go to that other slide that I had, whoops, wrong slide, this way. You can see how I solved that system. I like to insert the extra step here to get rid of the fraction, but you don't have to. You can work with fractions if you like, especially since you have a calculator. Notice my point of intersection is an exact answer using fractions. You need to do the same thing. Make sure those are given in fraction form. Otherwise your answer will be off, and it has to be accurate. And then plug that into the distance formula. So you can see how important that is to have the distance formula, because I don't think you want to calculate the distance between -2.5 and 13/10, by hand. That would not be fun. You think you have this, or do you want to do another one? Going once. Another one? Okay. Nathan, give me a slope. Positive or negative, it doesn't matter.
5/2.
And a y-intercept. Let's keep this as an integer value. No fractions. Positive or negative. 7. Okay. And Caitlin, where do you want the point to be located?
2.
Comma.
5.
2.5. Didn't we just do 2.5?
You did 5-2.
The -2.5.
2.
I have no idea how this is going to turn out, but we'll give it a shot. I'm guessing it's probably going to be pretty ugly because we randomized it. All right. We'll call this point C. We'll call this point D. Nah, not D, because we're doing distance here. Let's call it G. G never gets enough love. Find distance. What's the slope of that blue segment? Negative 2/5. If I lose anybody along the way, raise your hand and I'll slow down and or explain. Is everybody good on negative 2/5? Opposite reciprocal, also known as a flopposite. What's the equation of the blue line? Anna?
Y minus 3 equals negative 2/5, and then in parentheses x minus 2.
Good. And now we're going to solve the system between that line and that line. I can do substitution, I can do elimination. I'm going to do substitution again because I have this line already solved for y. So I get 5/2 x plus 7 minus 3 equals negative 2/5 x plus 4/5. Okay, so I did two things in that step. I substituted in for y and I distributed the negative 2/5. I don't like fractions, so I'm going to get rid of the fractions by multiplying by what? 5 first and then 10, then 2, or I can multiply the whole thing by 10, but I'll do 5 first. Okay, 25x over 2, or nah, let's not write it that way. Let's do 25 over 2x. 7 minus 3 is 4, times 5 is 20, equals negative 2x plus 4. Then multiply everything by 2. Which gives me, 25x plus 40 equals negative 4x plus 8. Oh, this is going to be ugly. 29x is equal to negative 32, so x is equal to negative 32 over 29. Ooh. Okay, but again, shouldn't be a problem. We've got calculators here. Question?
Can we put the x or the negative on the other slope? Like on the other side of the equation?
I lost you there.
Oh wait, never mind.
Okay. This point is at negative 32/29, comma. Okay, now I need to find the y value. So I'm going to come back up to this equation, because it's already solved, and y is equal to 5/2 times negative 32/29 plus 7. So what's y equal? On your calculator, by the way, you probably want to put that in parentheses. Lily?
Negative 80 over 29.
Can somebody confirm? Negative 80 over 29. Told you it'd be ugly. Okay. Negative 80.
Plus 7.
Oh, plus 7. Hold on.
Yeah.
Whoa. Whoa.
Okay.
Okay, so what's the final value?
123 over 29.
123 over 20. Wow, that's ugly. No. That's the hard part. The last step is easy. Use the calculator. To do what? Distance between point C and point G. And what do you get? 2 decimal places, please, because I know the radical is going to be ugly. Say again? Can somebody confirm? 3.34. Yes? No? Yeah. Yeah? Good? Okay.
How did you get 123 over 29?
I didn't. They told me that's what it was. I assume they used their calculators. So they did 5 halves, parentheses, 5 divided by 2. Close parentheses, times, parentheses, negative 32 divided by 29. Plus 7. And then convert that back to a fraction. Got it? Okay. So you see, all these little steps that we've been doing for the last week or so are building up to this, and we do have a further step past this type of problem. That comes later. We need to be able to master this first. All of the components should be in your toolbox, meaning you should have the skills in order to do this. The difficulty is remembering and or understanding what you're supposed to do. Okay. Find that point of intersection by solving the system between the 2 lines that you create. Then once you find that, that's the hard part, then do the distance formula. In order to do that, however, you have to have a distance formula running. Okay? So let me close this and stop the recording.